Hi everyone, it's Emma back with another GCSE chemistry video, and today I'm going to do a year 10 topic if you're wjec, but it doesn't matter what year you're in if you're AQA or edexcel, and it's group 7. So the elements that are in group 7, anything that's under that number 7. So we've got fluorine, chlorine, bromine, iodine. And you need to just know a few things about them, like group 1 really. It's group 1, 7 and 0. They are known, the group 7s, they are known as the halogens. I want to say halogens, but it's halogens. Just like group 1 are known as the alkali metals. And you need to know the properties of them. So because they're in group 7, they're non-metals. Remember this staircase. So everything in group 7 is a non-metal. They like to ask this question actually. Name the properties or a property of group 7 elements, and it is that they are toxic. Chlorine is in group 7. You've probably heard of chlorine being used in swimming pools. And it's used in swimming pools because it kills bacteria in small quantities. So, you know, we put a little bit in swimming pools to kill the bacteria. This can create a little bit of a misconception, which means a confusion, because we would then think, well, chlorine is a liquid, and it's not. So we'll get into that. So if you see a question saying what property, name the properties of group 7, well, they're toxic. And how are these used then? Well, they're used in swimming pools, they're used in cleaning products, things like that. Anything that kills bacteria, if you say that they use them in it, you'll get a mark. I've seen that question in the new spec. Next thing is the formula. I've seen this also be asked. So if you are asked to give the formula for iodine, so if they wrote the word down, sorry, I'm just writing them all down here. You need to know that all of group 7 always travel around in pairs. And that's because they've got 7 electrons in their outer shell. So they don't travel around by themselves. So if you were to write the formula for any of the group 7 elements, you would put the 2, a small 2 at the lower bit after it, and then you'd get the mark. You also need to know the those 4, you need to know each characteristic, I guess. So fluorine and chlorine are gases at room temperature. So I don't know why I've fluorine, chlorine, bromine and iodine. These are the only ones they want you to know about. There's only astatine after that. And what they do is ask you to predict a pattern using astatine. But you need to know that fluorine and chlorine are gases at room temperature. Make sure you remember that room temperature, because you can cool things down to make them condense and go into a liquid. But at room temperature, these 2 are gases, the top 2. Bromine is a liquid, which is an L, and iodine is a solid. All right. What this shows you is that as you go down the group, the boiling and melting points get higher. If you are solid at room temperature, you have a high melting point. If you are a gas at room temperature, you've already melted and you've already boiled. So as you go down group 7, the boiling points and melting points get higher. And they might give you a graph or something, or ask you to predict what astatine is at room temperature. Well, it's got to be solid because there's nothing after solid. Next thing you would need to know is how they look. So basically, you just need to know that the colours get darker. I've not actually seen them ask what colour is fluorine and chlorine, but it is in the spec. So fluorine is yellow. Chlorine is green. Bromine is like a brown red, but we say, and it gives off an orange, it gives off an orange vapour. And then iodine is purple. Now, what I think they're more inclined to ask is, what's the pattern of the colour? So they might say, well, predict what colour astatine might. Sorry, I got cut off there. Internal storage issues. I think I was getting to the point of them asking, predict how the colour of astatine. And all you would have to say is that astatine is even darker than the purple, because you need to remember that the colours get darker as you go down the group. One last thing I'd like to go over is the reactivity in group 7, year 7, in group 7. So when we done group 1, we saw that the reactivity increases as you go down the group, which means when you go down group 1, the elements get more reactive. Group 7, the halogens are the opposite. When you go down group 7, the reactivity decreases. That's the official term for it. But what it means is the elements get less reactive. So in group 7, fluorine is the most reactive element. Then it's chlorine, then bromine, then iodine. If your foundation and you covered the colours, that they get darker, that the melting points get higher, and the properties of them being toxic, so they're used in swimming pools to kill bacteria, or they're used in like antibacterial wipes and spray, then that is plenty of information for your exam. My next video is going to go into why the reactivity of group 7 decreases as you go down the group. Thank you for watching, and I'll see you next time.